For this problem, we're going to have 3 zeros that are here because there's 3 different pieces. So we want to fill all this information in and use that information to graph. So each of these individual pieces, you just want to think about what makes each individual piece equal to 0. So what number could I put in for x to make that piece be a 0? That's what we want to do to fill in the first blanks here. So if I put a 0 in for this one, that'll make that equal to a 0. Now the next one, I have a decimal here. So if I put in positive 1.5, so positive 1.5, 1.5 minus 1.5 will give me a 0. 0 squared is 0. For this one, I need to do negative 1.5 for that. Now, if you see a 0, one of your blanks has a 0 in it, automatically we can put 0, 0 for the y-intercept. The reason why is because for the y-intercept, this is when x is equal to 0. So if I put a 0 in here, everything's going to cancel out and give a 0 anyway. So if you have a 0 on one of these other blanks up above, there'll be a 0, 0 for your y-intercept that we have there. Now for the multiplicities, it's the powers that are on each of the factored pieces. The first one where the 0 came from, that's got a multiplicity of 3. And then each of these have a multiplicity of 2 because that's the power that's on each of these factored pieces. Whether the multiplicity is even or odd tells you whether the graph crosses or touches. If you have an odd multiplicity, the graph is going to cross, and that's what it does right here. But if you have an even multiplicity, it's going to touch. So it's going to touch on these other two here. The degree you can find by adding up all of your multiplicities. So if I add up the multiplicities, 3 plus 2 plus 2, that's going to give 7. So degree is 7. The max number of turning points is always going to be 1 less than your degree. So your degree minus 1 is how we find that. 7 minus 1 is 6. So that's the max number of turning points. Now for the behavior that's here, first of all, you're gonna just put x raised to the degree. So I know x to the 7th is part of the answer. Now I just need to figure out what number comes in front of this. Now in this case, there's a 1 in front of the x there. There's a 1 in front of this x. There's a 1 in front of that x. So when I multiply this part out, I'm going to get a 1x squared with some other stuff that comes afterwards. So I don't need to be concerned about that. This has a 1x squared as well. X squared, x times x is x squared. And then this is going to be a 1x cubed. So the coefficients in front of each of these are just going to be 1s, and which means I get a 1 in front of this one as well. So I can put a 1 there, or I don't even necessarily have to show the 1, but I will here in this case. So x to the 7th would be the answer for this. Now, before I graph this one, I want to figure out what the end behavior of this graph is. Okay, so for the end behavior, okay, I need to figure out the degree, and also I need the degree and the number that comes in front of the x with the highest power. Now, the degree we already did already. That's 7. So end behavior, you have to determine whether the degree is even or odd. So in this case, n is odd. And the a of n is the number that comes in front of the x with the highest power. In this case, the a of n would be greater than 0 because 1 we have here is greater than 0. If you look at the end behavior models that were mentioned in the notes, if n is odd and a sub n is greater than 0, then this is what the pattern looks like. It goes down, it might do something in here, and then it goes up. So that would be the end behavior, what it does. So that's going to help us to draw the sketch of this graph. Now let's plot each of these. We have a 0 here. We have 1.5, and then negative 1.5 and positive 1.5. So we have both of them there. So those are all 3 of the intercepts. Now we're going to use end behavior. End behavior says that we have to start coming up from this, from below. So I'm coming in like that. First of all, now at the negative 1.5, it touches right here, which means that the graph is going to bounce. So it means it's going to do that sort of shape. Now, when it crosses through at 0, at 0 here, that originally came from this first part. Now, this first part is an x cubed. And so anytime you see an x cubed, you have to draw a little bend in the graph. So this is going to come down to a certain point. I'm not sure what, and it's going to curve. I need to make it do this. I need to draw a bend in the graph like I see here. I don't want to have it just be a straight line because this is a cube here. So a cube means it's got to look like a cube shape when it goes through. So that's why I have to put a little bend in the graph, because that's what a cube graph does. This is going to go up again to a certain point. I'm not sure which one. And that's going to come back down to 1.5. Now 1.5, it touches, which means I need to do a bounce on that as well. And then it's going to go up. It's going to finish that because that's what the end behavior does. So we have a bounce. It's going to curve here, go down to a certain point. It has to go back through 0. That's going to be a bend in the graph because it's got to go resemble an x cube graph there. It's going to go up, turn again, and then it'll bounce at 1.5 and go up. So this one, if you look at the turning points, 1, 2, 3, 4, that works because this tells you just the maximum number of turning points. It doesn't have to have exactly that many, but it has to have less than whatever we have for that. And this certainly does fit that category. And so that would be the completed graph here.